Great. Now we're going to shift gears a bit and talk about the startups, have them present. But before that, I want to tell you a few things about the MIT Startup Exchange, how it can help you connect to MIT startups beyond the ones you see today. I'm going to share my screen now. Okay. All right. MIT Startup Exchange was created about 5 years ago based on input from ILP members like yourselves to better connect MIT startups, like the ones you see today and many others, with industry. These startups either licensed MIT technology, were founded by MIT faculty, staff, student, or alumni. We know these startups very well, and we also know our ILP members well. This enables us to make hundreds of effective introductions every year. It's really a great member benefit for you. Here are some of our success stories where ILP members have entered into partnerships with our MIT startups as early customers, strategic partners, or corporate venture investors. These members cover a variety of industries and come from all over the world. Here are some of the trending technologies from MIT startups. And there are a wide range of technologies, as you can see here. Besides the growing interest I mentioned in materials and sustainability, another third of requests we get are in AI and data analytics. There's also growing interest in IoT, healthcare, biomedical, and with COVID-19 too, we see growing interest in supply chain and logistics. So how can you best engage with these MIT startups? One great way is to attend topical events like today's. We'll be showcasing 8 startups, each of which will speak for a few minutes, so you can learn about what they do and discover a match for working together. Over the course of the year, we put about 100 startups on stage, so it's really a great way to get to know some of the best startups we offer. Related to today's event is our Sustainable Materials event on September 15th, where we'll be hearing about a dozen startups in raw materials and processing, applications and end of life and recycling. So do look for that. We also have our STEX 25 Accelerator program, which highlights 25 of the most industry-ready startups, ready for significant growth. We will unveil the next batch of STEX 25 on July 21st and 23rd, so do stay tuned. Lastly, you can be posting an opportunity posting, which goes out to 1,900 of our startups, who then can apply to directly work with you. You specify the topic of interest and the challenge that you have, and the startups can then self-select to match. Great, so that's about our Startup Exchange program. Now we're turning it over to our startups. In the first half, we'll hear from 4 startups working on advanced materials, followed by second half by 4 startups in sustainable materials. The startups will each speak for 4 minutes, and then we'll have 15 minutes of Q&A and discussion. So post your questions to Q&A using the Q&A button on the bottom. And do ask questions because that way you can learn more about whether they're a fit for your needs. If you have a question, it's quite likely that others in the audience also have the same questions. Now let's hear from our first startup, Rob Hilty from Xtalic.
All right. Let me share my screen here. All right. So hi, I'm Bob Hilty from Xtalic, and chatting with you a little bit today about nanostructured metal materials. So Chris Xu gave a great introduction. And I met Chris back in 2007 when I was an ILP member at a member company, and we sat down and talked about a problem we had in the connector space, and we ended up coming up with some really interesting opportunities. So what do we do? Metals, when we can make metals smaller, the grain size is smaller, you can improve all sorts of great properties. Hardness and corrosion resistance are 2 great examples. You see here in the image on the left, the hardness increasing by a factor of 8 as I reduce. Sorry.
The green button, share. Yeah.
Yep. Am I sharing now? Okay. Thanks for letting me know. Okay, so what we do is reduce the grain size of metal materials, and the image on the left shows you this dramatic improvement in hardness of materials as we reduce the grain size. The sort of Xtalic difference on the right is coming out of the labs of Chris Hsu and his work at trying to stabilize small grains. So normally when you make grains small, they want to grow, they want to stretch naturally based on thermodynamics. Chris and his team have discovered a way to thermodynamically stabilize those grains in a way that really makes for strong materials. So what we are doing is creating metal materials by electroplating in a way that drops into existing manufacturing capability. So in 2007, I met Chris. 2008, we came up with the backplane connector opportunity. Chris mentioned this briefly. What we're doing here is replacing the nickel that's normally used in connectors with our nanostructured nickel material, which allows us to reduce the gold and provide about a 40% precious metals cost savings on those materials by implementing a nanostructured metal material. Then we've expanded into mobile phone capability. So of the couple hundred people on the phone today, my guess is about half of you probably have one of our products in your pocket, or you're watching this broadcast right now using that technology. So we're in about 1 billion smartphones worldwide, about half of the top OEMs. And we have more than 10 billion backplane contacts. What we're moving into next, we see as an interesting market, is high-powered electric vehicle connectors. And again, we're looking at this opportunity to leverage nanostructured metal materials where we can benefit from having corrosion resistance and high strength and durability to give more power. When you want to put that Tesla into insane mode, we want you to be using our technology to help you get there. Other materials that we're getting into, we have an Xtalium product, which is a nanostructured aluminum alloy. Has all the strength of steel, but with the weight of aluminum. So pretty interesting and compelling factor there. Our nickel moly alloy has tremendous strength at temperature. So at 500 C, it's the same strength that you would have at room temperature, no loss at all as you use these materials. Again, leveraging that nanostructured metal background. So what we are using here is what we call our rapid alloy design platform. Again, leveraging that fundamental science out of MIT to create new alloys. And the table here shows you some of the things we've already started to work on. So lots of new opportunities. When a customer comes at us with a new opportunity where existing materials don't seem to match, we can use this design platform to create something brand new. So as an example of that, a sort of case study, we had a semiconductor company come and chat with us about how they're going to do more than more. And the goal here was to get improvements in conductivity, strength, fatigue. We took a look at this. We verified the value prop. We have to make sure that there isn't something existing that'll solve their problem. In this case, there wasn't. We invented a new alloy, a nickel gold alloy, had very low resistivity, really impressive strength, more than 2 GPa strength, with more than 1 million cycles of fatigue at 1 gigapascal. So exactly what they were looking for. So just to wrap it up here, partnerships of interest for us, thinking about electrical interconnects, medical, wearable, all of those sorts of things are great for us. Our headquarters are just outside of Boston, but we're globally located with manufacturing in about 40 sites around the globe. Thank you very much.
Thank you, Rob. Next, we have Steve from Allium. Steve, you might need to unmute yourself.
Okay.
Great.
Hi, you can hear me?
Yes.
Great. So I'm Steve Drapil. Thanks everyone for joining. I'm going to share my screen here. And so along with Professor Mike Short, I'm founding Allium, where we make layered metals for less corrosion at a lower cost. So corrosion, the main problem we're trying to solve here at Allium, is a really large problem. It costs hundreds of billions of dollars in the US alone yearly, and this amounts to a whopping 3% of the GDP. This cost is spread out over many industries, including transmission, drinking water, production and manufacturing. And each of these industries represent multi-billion-dollar markets for corrosion solutions. The reason corrosion costs are so high is not because there's a lack of corrosion-proof alloys. These alloys do exist, but they're many times more expensive than the typical structural materials we use, like carbon steels. So at Allium, we're trying to address this problem by making low-cost, corrosion-resistant composite materials in order to meet this gap. When we're picking from existing materials, we generally have two basic options. One, we can go with a corrosion-proof, high-cost material, like tantalum tubing used in the chemical production industry, which addresses this need for corrosion, but does it at a very high capital cost for your project. Alternatively, you can go with a low-cost material, like a carbon steel, which is very prone to corrosion, requires a lot of inspection, maintenance, replacement in order to operate, and incurs high operation and maintenance costs for your project. So what we're trying to do here at Allium is combine the best of both these options by creating corrosion-proof composite materials that are low cost. So what this typically looks like is a thin metal protective layer, like the one shown here, on a bulk low-cost structural metal to create this corrosion-resistant composite metal. One use case that can highlight the value our technology can add comes from a nuclear startup. So when this startup needed a large component to contain a very corrosive fluid under very high temperatures, we designed them a solution which looked like this on the right, where we had a thin layer of nickel to provide immunity to a low-cost Inconel structure. When we sought out cost estimates from vendors, we saw an 85% reduction in the cost in this case when compared to a Xtalic component, which would have been the state-of-the-art expensive alloy that would have been the alternative to ours. We're also exploring the possibility of reducing corrosion in things like pipes. The state-of-the-art here is something called cathodic protection, which sometimes involves applying electricity to a pipe in order to actively prevent corrosion. And this incurs high operation and maintenance costs to run, power, and inspect these machines. In some cases, it's especially difficult to use cathodic protection, like in really high density areas or in undersea transmission. So what we want to do is develop low-cost composite pipes to provide a durable corrosion barrier that eliminates this need for operation and maintenance costs, but does it at a much lower capital cost than an alternative like a pure stainless steel pipe. What we're looking for from all of you is partnerships and customers who have corrosion issues that lack low-cost solutions. So this could look like two things. It could look like a need for higher performance through increasing operating temperatures or pressures in industries like production, fluid transmission, or energy. Or it could also look like applications where inspecting and maintaining and replacing components is just not really a feasible option, and where we need durable composites to lower the cost for corrosion-proof materials. So if you're interested in talking to us about a problem, please reach out through the email address below or through the Startup Exchange, and we'd be happy to have a conversation with you. Thanks.
Thank you, Steve. Next, Ricardo for 2D materials.
Hello, everyone. Good morning. I'm Ricardo, and we are the 2D materials. So what we do, we want to expand the frontiers of materials application by the use of graphene. This amazing material that was awarded the Nobel Prize in 2010. And we heard a lot from the many industrial partners that graphene is very expensive and is for the future. And we are here to show that the graphene is for now. The problems that you want to solve, that they are related to thermal conductivity, weight reduction, sound absorption, electrical conductivity, mechanical strain, and corrosion. They are very common problems for the material science in the engineering space. And the graphene is used as additives to many other materials to to enhance these properties, among others. So basically, what we do differently in this space, our process is a top-down process that starts from graphite, and we manage to exfoliate this graphite in very thin layers of carbon atoms, the graphene layers, below 10 layers. This means less than 3 nanometers in thickness and then 1 micron in lateral dimension. This height quality can be translated into a height performance when we add this material to other industrial materials like polymer coatings and so on. The other differential is that we can do that in a very high yield. We can convert 1 kg of graphite into 700 grams of graphene, and no company can do that. So we can offer the best cost performance ratio in the market so far. So, and this comparatively, this gives us a very advantage upfront against all these competitors. And I want to share with you some real life products that we are working with some partners. This is a company in Australia which produces tactical helmets for police and defense. And they add our graphene to that epoxy resin, and they managed to get a 15% increment into the ballistic protection. So since they don't want to make thicker helmets, if they keep the ballistic protection to the same level, they can reduce the weight by 20%, and the helmet can weigh by 1 kg. The second example is coatings industry in Singapore. Is one of the top 5 coatings industry in the world in the marine space. They have tried graphene before. They complained that graphene didn't work very well. Then they tried our product, and they managed to get 140% in the salt spray. And this can be translated in more than double the lifespan of the coating. And as a third example is a battery manufacturer in Brazil. They do lead-acid battery for hybrid vehicles. And one of the problems when you hit the brake, all the energy cannot be transferred to the battery. So if you add a small amount of graphene to the electrode, you can get at least 30% increment on that. So what we are looking for, we're looking for a commercial partner to do pilot trials with us. The areas is high performance composites for defense, aerospace, oil and gas, anti-corrosion, anti-fouling coatings, marine, heavy industry, and so on. And also, of course, electrodes for batteries for electronics. Thank you.
Thank you, Ricardo. Next, we have Joe from Kebotix.
Hello, everybody. Can you hear me? Hi, everybody.
Yes, yes, we can hear you fine.
Thank you for having me today. I'm going to share my screen now. I'm Joe Becker, CEO of Kebotix, and I'd love to tell you a little bit more about what we do. So the problem that we're trying to address is what we call the R&D productivity chasm. So if you think about chemicals, materials companies, they're very good at what they do. They do large-scale production, and they sell chemicals in large quantities. And they spend over $150 billion a year to try to dream up new chemicals. Now, OEMs and end product manufacturers have a huge supply for new materials, and the chemical companies simply can't deliver these new materials. And the reason for that is we're using 18th century methods, and that means that the discovery is too slow. It takes at least 10 to 15 years to get a chemical into an end product. I myself had an idea for a chemical in 1999 that went into the chips that you and I use every day. And I got a check 20 years later. And we really have to address this timeline and especially increase the success rate. And this is where Kebotix came up. So we have reinvented how to invent by taking artificial intelligence and robotics to increase the rate of discovery. Now we have very strong material informatics tools. What you're looking at here is actually the scientific method that we have automated. So now instead of a scientist romantically dreaming up how a hypothesis of what chemical to create, we now have our AI methods to predict accurately what chemical you should be making. And we also had built a route predictor, including retrosynthesis, so it can predict how you would synthesize this. Then we have some lab automation that synthesizes the top candidates, another robotic suite that tests, just like a chemist, did you make what you said you're going to make, and does it have the properties of interest? And we're actually left with a chemical at the end of the day ready for prototyping. And we did this with the 21st century tools of AI, and we've built the very first self-driving lab here at the Engine, which is a for-profit incubator run by MIT. We also call this the closed loop innovation platform. As an example, we, especially in the times of COVID, we can also control labs remotely. On the right, you're looking at a yellow robotic arm from the NIH NCATS that is used to test for viruses. And we control their lab remotely in order to do high throughput experimentation for enzyme assays, and in order to optimize 3 variables: enzyme, substrate, and time. So their brute force design of experiment normally takes 49 hours. And we managed to reduce that down in very short order to 9 hours, giving them 40 more hours to save lives. And yes, all they're doing right now is COVID testing. And at the same time, we managed to reduce the amount of enzyme they need by a factor of 5. What we're looking for is more partnerships. The idea is, how can we help you create chemistry faster at a reduced cost? What problems can we help you solve? How can we help you reduce your R&D costs? And we do that by providing our partners with our digital tools or complete solutions, anything from that we can develop new materials and chemicals to your specifications with or without your data, because we have the ability to create our own data, which is very important because often the data sets are too small to do machine learning on. And we can also optimize existing processes and reactions and dream up. We just came up with a new green monomer for sustainability and packaging. Examples of partners include things like chemical companies, OEMs, oil and natural gas, beauty companies, and food companies, things like that. Thank you very much.
First, we have a poll we would like to run to understand a bit about your concerns around advanced materials. So we want to get that poll going. And then we want to assemble a group of advanced material startups and ask them a few questions. Cool. Great. Here's that poll you can answer while we get some of the questions going here. Yeah, so I see a number of questions posted by our audience. Let's just jump in and answer some of them. For Allium, how do you overcome the difficulty of joining layered pipes? You might be on mute.
Sorry, can you hear me now?
Okay, yes.
Yeah, can you hear me now? Great.
Yes.
So I think that's a really great question. And the short answer is, because we have metal layers, you can weld the layers individually from the inside out, taking advantage of filler metal. But to go into more detail, I think would take too much time, not be appropriate here, but it's something we're exploring, and I'd be happy to talk about that more.
Mm-hmm. Great. And then for 2D materials, do you have a sense of the price savings versus other graphene manufacturer with a similar quality product?
Yes, we have this sense. In some cases, the savings can be over 70%. This is why quality is very important. And one fact that is going to help the graphene market is also the ISO standards around graphene that they are about to be published then this year or the next year. This is going to help to the customer to understand what is the value of quality also. Thanks.
Great. For Xtalic, we have a question for you about what size of volume are you capable of producing? Their understanding is that your product forms a thin film, which reduces the utility of like the aluminum product. Is that so? Would be great if you could speak to that.
Sure, it's a good question. So we make most of our products by electrodeposition, so it is sort of a bottoms-up atomic level growth. So thinner films have a tendency to be a bit more economically viable. However, we've plated the aluminum up to about 1 millimeter thick, so you can make real structural components using this. When it comes to lightweighting, one of the other options you have, we have the ability to electrodeposit aluminum onto magnesium. Magnesium is a great lightweighting option, and the aluminum then provides you substantial corrosion protection, which is really the Achilles heel of magnesium.
Also have some poll results to share, right? Looks like performance and cost are both important to folks, and then more importantly, balancing the different needs. That seems like a good topic for the panelists to speak on. Please feel free to pipe in. What do you think about this balancing different needs? I guess in particular, performance and cost being one of them. Yes, Rob, please.
Yeah, so balancing cost and performance is key, right? So what you want to do is think about what those options are. In the case of like our gold savings opportunity, it was really about cost reduction, where we could offer about a 40% cost reduction. In the case of the mobile phone application, we actually have a pretty substantial boost in performance that was really unavailable before. So it does really depend on the particular application, but cost is always important when you come to implementing a new material.
Anyone want to add to that?
Yeah, Ricardo from 2DM. We feel more or less the same. The performance and the cost balance is different for depending on the product that we are developing. For some products, the performance weighs more than the cost, and some the opposite. But we must have the flexibility to change from one way to the other. I think this is the important message.
Mm-hmm. Flexibility. I think Professor Xu mentioned that earlier too.
Yeah, exactly.
Great. Next question is for Kebotix. How well do you see AI's role in your work with the materials development? Is AI overrated? I think that question comes up a lot about AI.
I don't think that the AI is overrated in terms of Kebotix. I do agree that it is an overused term. When I was raising my seed in Series A, I always joked that I had, 3 out of the 4 buzzwords: AI, robotics, machine learning, and all I had to add was blockchain. And then I'd sort of have all the areas that they wanted to invest in covered. But what I've seen my team do for our partners and also for ourselves, because we're growing to be the chemical company of the 21st century, has been pretty impressive. So we just closed our Series A. We hit our business and technical milestones early, although we're a tough tech company. As Professor Xu correctly said, it often takes more time and is more capital intensive. But being the CEO of a VC-backed company, I know that part of my job description is that regardless that it's a tough tech company, I have to raise every 18 to 24 months. So I don't think the AI is overrated when it comes to Kebotix.
Maybe you can speak a bit about how can AI help address, for example, this trade-off between performance and cost, as an example, to help us think about how to apply that AI in materials development.
You can have different descriptors. I think part of the cost savings is, for example, recently a company came to us and they had dreamt up 2,300 possible lubricants. and it would take them hundreds of thousands of dollars and years to make them all. And so they were interested, and it wouldn't surprise you because it's a lubricant, boiling point, vapor pressure, and viscosity. Viscosity is how a liquid runs, think honey versus water. And we were able to rank all 2,300 for these properties. And we built them actually a web portal with they could toggle properties 1, 2, and 3. And then they only made the top 4 candidates. And what we were happy about, that our prediction was totally accurate. And we couldn't have done that without the AI and all the associated tech that we have around that. Because if you think about it, 2,300 data points that they gave us isn't enough. And that was just a structure that had nothing to do with properties. We had to build the rest because you need at least 250,000 data points in order to machine learn.
Thanks, Joe, for that.
So you can see the performance and cost right there. So we saved them, for example, a lot. And then for a big company, we came up with this green monomer, and part of a synthetic route for that. And part of it was we had to come up with a cost-efficient way. So one of the things we have done is we've uploaded all the commercially available chemicals worldwide into our AI software, including price per gram and also the vendors, because cost is always an important driver.
Certainly. Yes, one more question for 2DM. What work have you done in terms of thermal spreading, and how do you compare to existing graphene sheet suppliers?
Yeah, we are looking to this area, of course. The thermal spreader became very famous because of the cell phone Huawei, the Mate P20, one of the first products with graphene. In terms of performance, we can match the performance as well, but the problem is the volume. We don't have yet the volume to become a supplier yet. We are producing currently 12 tons of graphene per year, but for application like this, you need maybe 10 times this volume. But in terms of performance, we can match. Yeah.
Great. As we're wrapping up here, any last words on corporates looking to work with you? How can they best engage with you on some of these different topics that were brought up?
I mean, for us, we're just looking to solve your problems at a reduced cost. So feel free to reach out to me or anyone from my team. We're also in the process of hiring, and I'll also be reaching out to Dr. Xu. Happy to help. I've been a BMS mentor. I've been a judge for MIT 100K, but I think there's a lot more that we can do to commercialize tough technologies.
Yeah, and from our side, feel free to write to us. If you need graphene to do any trials, we are really open to discuss partnerships, especially to generate data, to prove the performance and to move forward. Thank you.
Bravo, Steve. What are some of the best ways?
Yeah, so I welcome you to go check out the website, Xtalic.com. There's a lot of good examples there about the work we're doing and fundamental technology applied. Reach out, happy to chat with you about interesting problems.
Yeah, I think when it comes to Allium, we have such a flexible technology that we're really looking for problems. So if you have a problem and you want to run it by us, please reach out. We can jump on a call, and I'd love to just talk through what are the things that are keeping you guys up at night and how can we be a part in solving them.
Great. Thank you so much for our panelists. We'll also be running a poll later on today about the different startups that you want to follow up with. So do answer that, and we'll try to do our best to connect the both sides. Thank you, our startups on advanced materials.